Hello everyone, I hope you're having a wonderful evening. We're going to be going through the trig values of special angles, or the measures of special angles section of the Unit 10 trigonometric functions packet. This has a lot to do with the Pythagorean theorem and how trig fits in with that. So we're going to talk about some special right triangles. So there's two specific right triangles you need to know. The first one is an isosceles right triangle. Isosceles right triangle, the measures have to be the same because you know in an isosceles triangle the base angles are the same. So down here, if we make this the two sides of this right triangle 1 and 1, we know that this angle is going to be 45 and this angle up here is going to be 45. So the measures of the angles of an isosceles right triangle are acute angles, and they are 45 degrees. So we're going to use this to figure out sine, cosine, and tangent. So the very first thing we want to do, we know that sine of 45 is going to be opposite over hypotenuse. Well, just using our angle right here, we know the opposite already is 1, but we don't know the hypotenuse yet. So we need to figure that out. In order to do that, we're going to use the Pythagorean theorem. So a squared plus b squared is c squared, so that's 1 squared plus 1 squared equals c squared, or 1 plus 1, which is 2. And then we are going to take the square root of both sides of that. So c, we are just going to leave as the square root of 2. So this other side up here is going to be the square root of 2. So when we do this now, the opposite is 1 over the square root of 2. We can't leave it like that. We have to rationalize the denominator, going back to the chapter on radicals. So we're going to multiply both the top and the bottom by radical 2. So on the top, you're going to just have the square root of 2 over, and radical 2 times radical 2 is just 2 if you put that in your calculator, which is your final answer for the sine. For the cosine of 45, we're going to use adjacent over hypotenuse, which nicely enough actually ends up to be exactly the same, because the adjacent side to 45 degrees, adjacent is right here next to it, is going to be 1 over, and the hypotenuse is still square root of 2. Again, we want to rationalize that denominator, and you'll end up with, again, radical 2 over 2. And if you think about the complement stuff we were talking about in the last section, you should know that 45 and 45 are complements here. So the sine and cosine of them should be equal. And for tangent, tangent is going to be opposite over adjacent. Well, the opposite is 1. The adjacent is 1, so we just have an answer of 1. The tangent of 45 degrees is 1. So that's the first special right triangle that we need to know, is an isosceles right triangle, also known as a 45, 45, 90 right triangle. You might want to make a note of that somewhere in your notes. It's not there, but that's a 45, 45, 90 right triangle. The next triangle we want, we're going to actually start with an equilateral, but we're going to go ahead and drop a line right down the middle. So this is going to be what's called an altitude, so it is a right angle there. Well, in an equilateral triangle, we know that the measures of all the angles is actually 60 degrees. So the measure of angle A over here is 60 degrees. The measure of angle A, B, D. Well, in a right triangle, if you drop an altitude, you'll notice that this right here is bisected, so both of those angles are the same. So if they're both the same, that means this one has to be 30, and that means that ADB, this one right here, is our 90-degree angle. So this type of triangle, and again, we're just going to be looking at this piece right here, this side of it, is what's called a 30, 60, 90 right triangle. We're actually going to change this here. I want you to change this 1 to a 2 because it makes it a little easier to remember. Change that 1 to a 2. Really crappy 2. Okay, so if AB is 2, so we're going to say this is 2, then AD is what? Well, in an equilateral triangle, all the sides are equal. So this is 2, but again, this has been cut in half. So AD, the piece right here, is going to be 1. So AD is 1. And now we want to find BD, this other piece right here, the line going up and down. So we're going to go and use a little bit of our Pythagorean theorem action. So it'll be a squared plus b squared equals c squared. And this is a little different because you'll notice that 2 here is our hypotenuse. So 2 squared will be over here. So we have a squared plus 1 squared equals 2 squared. Or a squared plus 1 equals 4. If we subtract 1, we get a squared equals 3. And then we square root it to get a equals the square root of 3. So BD is the square root of 3. And the reason I changed that to a 2 is because in a 45, 45, 90 right triangle, your sides are 1, 1, and 2. And in a 30, 60, 90, you're going to have 1, 2, square root of 3 as your side lengths. But that's something we'll talk a little more about in class, the side lengths and how it's easy to remember that. Looking now, from that triangle, we can figure out, and again, I don't have it up here, so you have to look into your paper there, but you can find the sine of 30, which is opposite over hypotenuse, cosine of 30, which is adjacent over hypotenuse, tangent of 30, which is opposite over adjacent, and then the 60 degrees also. So I'm going to go ahead and give you the sine ones, but I would like you to figure out the cosine ones on your own. So the sine of 30 being opposite over adjacent, that ends up being, opposite over hypotenuse, it's 1 over 2, or 1/2. Cosine of 30, well, we figured out that adjacent is the square root of 3 over 2. And the tangent of 30, opposite over adjacent, is 1 over the square root of 3. But we need to rationalize that denominator. So we actually end up with the square root of 3 over 3. Again, what I'd like you to do is go ahead and find the sine of 60, the cosine of 60, and the tangent of 60 on your own. They're in this next table also, but I am not going to be foolish and give it away. So those you'll have to fill in here, and then to make sure it's correct, we'll fill them in the table tomorrow. So, speaking of that, looking at our table on the next page, we could fill some of these in prior to this lesson. So the sine, cosine, and tangent of 0, we can remember that they were 0, 1, and the tangent was 0. We'll do 30, 45, 60 in just a second. And then the 90, we actually already made a table similar to this a couple sections back. 90 was the sine was 1, cosine was 0, and the tangent was undefined. For 180, we had 0, -1, and 0. -1, 0, and undefined again. And then 0, 1, and 0. And again, oops. Each of these pieces here is back from the unit circle section. So now we have our 30, 45, and 60 angles, which we're talking about now. So we know in a 30-degree angle, the sine is 1/2. The cosine is square root of 3 over 2. And the tangent is square root of 3 over 3. Our 45-degree angle gives us square root of 2 over 2, square root of 2 over 2, and 1. And again, I'm not going to be silly and fill this in. I want you to fill these in on your own, based on what we did just a second ago. We're going to go through example 1 right now, which it looks really confusing, but if you take your time and think about it for a second, you'll be able to figure it out. So, we know that to start, let's get all of these things in terms of sine and cosine. So let's start with secant. Secant, if you recall, the reciprocal function of that to get it to look like sine and cosine is 1, right underneath it, 1 over the cosine of 30. We know that cotangent is cosine over sine. And these are both 45. And sine of 30 is already in terms of sine. I'm just going to put it over 1 to make everything look the same, so it's all fractions. Now, if we go ahead and fill in what we know, well, we know that the cosine of 30 is radical 3 over 2. So this is 1 over, and it's going to look scary, but it'll be okay, I promise. Just take a breath, write it down with me, and see if you can figure it out as we're going. So the cosine of 30 is the square root of 3 over 2. Cosine of 45 is square root of 2 over 2 over the sine of 45 is square root of 2 over 2. And I know what some of you are thinking already. Don't say it, don't cheat, don't tell anyone. We'll get to it in just a second. And sine of 30 is going to be 1/2. And again, I'm going to put that over 1 just to make it all look the same. So I'm sure that some people already noticed that you have the square root of 2 over 2 over the square root of 2 over 2. And yes, that can most certainly be changed into just a 1. So essentially this cancels itself out. And you just have 1 over radical 3 over 2 times 1/2 over 1. So the 1's are gone, and you end up with 1/2 over radical 3 over 2. And I'm going to go through this quickly just so that everyone has the knowledge that this is a division problem. We know that fractions are division. So this is saying 1/2 divided by radical 3 over 2. And when you're dealing with fractions and division, you have to get some fried chicken. So you end up with 1/2 times 2 over radical 3 when you flip it, which the 2's will cancel, and you end up with 1 over radical 3, which when you rationalize that, I'm going to run out of room. I tried to keep it over there. Let's make a big arrow. I know this is going to look confusing. And when you rationalize that, you end up with 3 over, radical 3 over 3. And the only thing I'm going to say is that if you wanted to be super, super fancy, you would look up here and you'd say, okay, this is radical 3 over 3, which is right here, which is the tangent of 30. So this is a good answer. This is a great answer. What I would like you to do is we're going to do number 2 in class because it is a little tricky. We have to draw a diagram, but it'll be okay, I promise. No one will cry too hard, and we'll have tissues in case you do. But I would like you to try number 3 here. And you'll notice that it's asking about cosecant of pi over 4. This is in radians. So you're going to need to use what we learned in the past about changing from radians to degrees. And there was actually a whole section on that. It was 1, 2, 3 sections ago. Radian measures of angles, and we talked about how to change from radians to degrees and degrees to radians. So if you change from radians to degrees, then you can use this table up here to figure out exactly what the answer is. I know that cosecant isn't in there, but sine is in there, and you can use sine to figure out cosecant. So use the radians to degrees, and then use the cosecant to sine to figure out the other part. So try that one on your own. I will check that in class tomorrow to see who has it done and who doesn't. As long as you give it a try, you shouldn't have a problem. Other than that, we'll go over number 2 in class. Have a wonderful evening.